Welcome friends, I am Tanmay. I welcome you all in my channel Chemistry of Molecules. So today I shall explain the stereochemistry of Wittig reaction. In first part of this video I have described about Wittig reaction, the basic concept and mechanism. So I will explain today stereochemistry. And what do I mean by stereochemistry? Stereochemistry means what type of alkene, means E-alkene or Z-alkene, or we can say Trans-alkene, or Z means Cis-alkene. It is very little confusing how to remember what is E and Z. Means actually the thing is completely different. E means both are three lines same side, so alkene should be anti, means trans. Z means two opposite sides, alkene should be cis. So this is the way to keep this factor in mind. Let's start. Here you can see that if this ethyl triphenylphosphonium with benzaldehyde produces trans-alkene, cis-alkene 87%, this is the major product. Similarly, if we take styrene based, means benzyl substituted Wittig, here the trans is main factor. Similarly, if we take this Wittig reagent having acetate attached, then trans is also major. So from these three examples we can understand one thing. Obviously reactions are done under anhydrous condition. That reaction with benzaldehyde, where the Wittig reagent is attached to an electron rich, then it produces cis as a major product. But when the Wittig reagent is stabilized, means electron delocalized or electron deficient, little bit we can consider, because this negative charge is stabilized by the conjugation with the benzene ring. So this produces trans as a major product. So here the similar, the reagent is stable due to the conjugation of this charge with this acetate group, it is major. So what is the conclusion of this story? So it's a trick, you can remember the product. Stable Wittig reagent, will produce stable alkene. In this way you can remember, and we know if we compare cis and trans is more stable. So stable reagent will produce stable alkene, and stable alkene means actually trans. And unstable reagent will produce unstable alkene, that is cis. Okay, so same thing you can see, this is stable reagent produces trans. Okay, stable reagent produces trans-alkene as a major product. This is stable, produces trans. This is unstable, produces cis. And actually it's a mixture obtained, and major product is the cis one. So right now we will explain the fact why and how this thing is happening. Let's discuss about the mechanism. How this stable is producing stable alkene, means trans and cis. Okay. So let's check the first one. For example, let's consider this one is unstable reagent, unstable Wittig. Okay, so it is expected that it will produce unstable means cis-alkene. Question is how? First of all, this reaction will produce in this way. Actually, this is the carbonyl. I am right. I have written the double bond here, but actually this is, and phosphorus should be plastic. So this carbonyl will attack this carbon, this center, and then it will open. So what happens? That it will come and attack with around bargaining trajectory, addition to the carbonyl group. Similarly, so what happens? It proceeds through this way. So this attacks, is dotted bond or bond formed or broken during the transition state. So this center, the nucleophilic attack happened, and consequently this bond opened up, and we know that this oxygen loves to phosphorus because of oxygen phosphorus bond energy. This thing I have explained in the first part. So it will form a bond. Now after that, it's right now it's a 4-member ring, and we know 4-member ring could be explained in such a way, because if we draw 6 member in this way, so we can explain that if we remove this part and remove this part also and add this, it will be 4 member. It is strange, but it could be considered in this. It's a pucker shape. So what happened this? So if we write this thing properly, means what do I mean? I mean that if we let this part little up, okay, and let this part little down, so it looked like the oxygen is all previously in the bottom. So bottom, this is the triphenyl phosphine. This went little up. So previously it was in the plane, and actually this carbonyl group, this hydrogen is above this plane of the board, and this is behind the plane of the board. So if we lift it out, then hydrogen will come to this equatorial type side, this, and R group will come down. Similarly, since this is up, so it will go to up. This is in front, so it will go to up, and this R will go little down, means this equatorial side. Okay, this is fine. This is the actually transition state. What should look like? So this is right now a 4-member ring, and this oxygen means actually it's an oxygen intermediate, and you can see these R2 and R1 is in cis conformation. Or if we write it little easier, what does it look like? This is the oxygen, this is the PPH3 unit, they attached, and these are, if we consider this R is R2 is down, then this hydrogen is up. Similarly, this R1 is down and hydrogen is up. Okay, so this means they have some static repulsion. And another thing, in this way this bond breaks and this produces Cis-alkene. So this will produce Cis-alkene. Okay, unstable Wittig, unstable alkene, Cis-alkene. So this, and why? Because these R1 and R2 are cis to each other. Okay, fine. Similarly, if we consider a different way, for example, this is the case of trans. So this is stable alkene. So what happens here, that this will be attached, everything will be similar, only position of R1, R2 is changed. So since R2 is in front of this board, so it will go up. So if I draw it in that way, it should look like that. R2 is up, this hydrogen is down, and here R1 is down, hydrogen is up. So if, this is PPH3, this is oxygen. So if it undergo this cleavage, it will produce this. Okay, so you may have a confusion, where should go? I am always trying to bring this to this, not another one. Means what do I mean? That PPH3, if we consider, I am not showing this. Why? Because if I remove this bond, partial positive charge will go on oxygen. So that is little unfair. Although it's a pericyclic reaction, that doesn't matter. But more logical is in this way I am pushing. So okay, fine. So this, what it will produce? It will produce a trans-alkene. Trans-alkene means here this R1 hydrogen, and so it should be opposite, R2 hydrogen. So stable will produce stable, that is trans. Okay. Now question, why this is happening? Actually, if you see that when these reagents come closer, this is the hydrogen, small molecule. So interaction, and this interaction is minimum. So it will be, so this is kinetically favored. Okay. So this transition state is kinetically favored. Fine. Because this is less bulky, and another thing, hydrogen this side, so this is coming, and similarly this is above the plane, so interaction with the bulkiness associated with this will be less. So this is kinetically favored, this. So the cis product is kinetically favored product, but trans one is thermodynamically, because this is cis oxygen intermediate. So how this is So right now here you can see this bulky R2 is here. So it is true that there is some interaction to produce. So there is some steric repulsion for this bulkness of R. And so this, and second point, that here there is a steric repulsion between R2 and R1. So the transition state associated to cis-alkyl production is high energy, associated with this high energy. Okay, but here this transition state is associated with low energy. That's why. That's why this will fail. Okay? Okay, fine. So you may have a question that why in this way reaction will go on, because in the reaction medium I do not have any control. It should have similar. It's true. You can consider that, okay, this kinetically, everything reacting with kinetically, no problem, fine. But after that, this intermediate is produced, this cis-oxygen intermediate produced, they can undergo reversible change into the trans one. How? This is a reversible, so right now in the reaction medium, if the Wittig reagent is stable enough that it can stabilize during, it is stable by itself, then it can reverse back and the same reaction happens if the Wittig reagent is stable enough. So in this way, during the reaction, that could be converted into thermodynamically favored. Okay, so this is thermodynamically favored. Okay, okay. So we can explain this factor in little different way also. How? We can draw an energy profile diagram. What do I mean? Means, see, here the Wittig reagent, for unstable Wittig, reaction is higher. This is UNS, and this is the energy of this stable Wittig. Okay, higher. So it can undergo reaction easily through a transition state to produce a stable. Actually, compared to Wittig reagent, alkene is stable. So the product is stable. Second of all, phosphorus oxygen bond is forming, that is also stable. So consider this is. So I should not make that much thing. This is ST. This is. Okay. And here cis-alkene, so stabilization will not be that much. But if we consider the stable, so reaction here, the reaction could have relatively high, energy barrier, but product is also, because here alkyl is cis-alkene and here difference is that is trans-alkene. So it is trans-alkene. Energy of activation is higher, but since it is stable, that it can remain in the reaction medium for a long time, so this reaction can follow this pathway to produce trans-alkene. Means what? In physically, these undergo equilibration to form this one where it is less. Okay, for stable one. Unstable one, it will go this path and directly produce the cis-alkene. So in this way, you can consider this energy profile diagram. Although it is energy of activation is higher, but it goes. Second, another, that it may follow this path, kinetically follow path, but how can it come back? Because kinetically follow path energy of activation is less, but the backward reaction energy of activation is also not significantly higher. That's why that transition state can come back from that. I'm not saying that alkene will come back. Means, what do I say? Since this is not that much high, so from that it can come back, and if from that it can come back, and if it is not, it is higher also, then it will not come back. Okay, so this is, you can consider kinetic. This is kinetic versus thermodynamic. You can represent this factor in this way. So this is the end of this discussion. Now the question comes, is it possible to get Wittig reagent at a particular alkene exclusively? Because whenever I am saying that Wittig reagent is stereoselective, okay, regioselective, okay, fine, that cis trans possible, but it produces a mixture in first half. I have given example, there is a mixture that, okay, in case of one product predominates major, but it doesn't say that it is exclusive. So is it possible to use Wittig reagent reaction and directly and get a particular product? It is possible. The use of a lithium salt, that is a salt effect. So that thing I shall explain in the next video. So if you like my teaching, please give a like, subscribe my channel Chemistry and History of Molecule, and share this video among your friends, as that many people could be benefited from my effort. And finally, please press the bell icon to get the notification of every single video I upload. So see you in my next video.